and the relevance of it to the present times. Climate change and healthcare. Climate change means usually we refer to the change in weather and the change in temperature or the global warming. There is very little difference between climate change and global warming. We will concentrate on global warming. The second question comes, does global warming has any effect on health? We healthcare workers, should we be concerned about it? WHO says the climate crisis or climate emergency is a global problem. It is the greatest threat to the global health in 21st century. As per the estimate of WHO, 265,000 deaths will occur every year in excess due to global warming. So we, the health workers, should be concerned about it. Climate change, global warming will affect every aspect of our life, starting from agriculture, economy, and health also. So we cannot be silent spectators in this scenario. Today, when we are talking about global warming, the word global warming is relatively a new word. It only came to use in 1975. Within a short period, we know the effects of global warming. So we will cover these aspects, like what is the greenhouse effect, what are the major greenhouse gases, global warming since industrial revolution, and what is the tipping point, and the consequences of global warming, and who is responsible for it, both at present, historically, and who gets more affected by it, the rich or the poor. There are many other aspects of the subject, like COP, Kyoto Protocol, Paris Accord, net zero emission, carbon credit. Within this short time, we cannot cover all these things. Let's start from the greenhouse. We all know for better growth of the plants or the saplings, we have greenhouses. These greenhouses are covered by either by glass or by plastic, polyurethane. How does it work? The sunlight comes through it inside the glass house or the polythene, which is transparent. The visible light passes through the glass and it hits the atmosphere. And inside the greenhouse, the atmosphere remains warm and cozy for the plants to grow. But the process of greenhouse and the greenhouse effect by the greenhouse gases is slightly different. Here it prevents the convection of the, but in that case it is radiation. When sun's radiation comes to the earth, some part of it gets absorbed and 30% of it gets reflected. And this reflected radiation, mainly the long wavelength radiation, this is captured by the greenhouse gases, mainly carbon dioxide, methane, nitrous oxide, and CFC. Even water is also considered as a greenhouse gas. But we can take it as a effect of the or feedback when the global temperature rises because of the greenhouse gases. There is more vapor and it adds to the discomfort, it adds to the greenhouse effect. So this molecules of greenhouse, uh, green gas, they absorb the radiation and they get heated and they radiate, and that makes the earth hotter. So they work as just the mechanism is like that of a blanket. If we look at the composition of air, the most abundant gases in the air are nitrogen, oxygen, argon, carbon dioxide, and some other gases. 78% of the air is nitrogen, then oxygen is 21%, argon is 1%, carbon dioxide is 0.04%. These are the major greenhouse gases: carbon dioxide, uh, um, methane, nitrous oxide, and CFC. The major greenhouse gas is carbon dioxide. Then comes the methane. If we look at the structure of the greenhouse gases, first let us look at the abundant atmospheric gases like the nitrogen and oxygen. They are transparent to the radiation, means they don't absorb radiation. The radiation goes through it because they are simple molecules. If you look at the nitrogen molecule, there are two nitrogen atoms, oxygen, two oxygen atoms. But if you look at the greenhouse gases, they have two different type of these molecules. They have two different types of atoms. Like carbon dioxide has C and carbon and oxygen. Methane has carbon and hydrogen. Nitrous oxide has nitrogen and oxygen. These are the fluorocarbons, are the CFC. CFC 11, CFC 2. They contain carbon, fluoride, and chloride. Usually these are synthetic. They are not naturally found in the atmosphere. Used in as refrigerants, blowing agents, and cleaning agents. Then why do these greenhouse gases absorb and radiate infrared radiation? Because of the chemistry and physics of the molecules. The abundant gases are simple molecules, which I have already discussed. The infrared radiation passes through them, but greenhouse gases absorb radiation and they stretch and bend and vibrate. They radiate heat in all sides. Let us look at the carbon cycle. What happens in nature, where from carbon comes, or carbon dioxide comes, and how it is absorbed in the atmosphere, or in the what is the natural carbon cycle. The most important thing is the burning of the fossil fuels. Fossil fuels consist of coal, oil, and gas. For energy, this is the most abundant supply of fossil fuels is there, so we use it more commonly, and we release carbon dioxide to the atmosphere. Then comes the plant's respiration. Plants do produce a certain amount of carbon dioxide. Animals and human beings do have, by respiration, we leave carbon dioxide to the atmosphere. And deforestation. These are the things by which carbon dioxide comes to the atmosphere. But by natural method, atmospheric carbon dioxide is absorbed also. The plants take carbon dioxide for its photosynthesis. And the oceans also absorb a certain amount of carbon dioxide. And plants, when they are dead, they give it to the soil. Carbon enters the soil. And the fossil carbon again comes here as coal, oil, and gas. This is the natural carbon sink which we have discussed. The forests, plants take out for photosynthesis. If there is reforestation, 37% of the carbon dioxide can be absorbed. This carbon is fixed in the soil. Then the oceans, carbon dioxide dissolves in the seawater. Then it accumulates in the deep water as a part of the carbon cycle. Then comes the blue carbon ecosystem. At places where fresh water meets the seawater, like the mangrove forest of Sundarbans, they store 4 times more carbon than the terrestrial forests. This is the methane cycle, where from methane comes. It was the usual concept previously that the methane comes from the agricultural waste, mainly from the cows, uh, from the milk industry. But the oil industry produces more methane than from agriculture. The fossil fuels, when they are produced, this is a byproduct and leakage from the storage sites and in the production site that goes to the air. Other small part comes from the biomass or from the wetlands. This is from the natural gas well sites, how methane comes from that. During the process of production of the oils, there is routine venting and leaks from the wellhead components. And during transportation, there is a leak. From satellite imaging, it has been seen that leakage from this production site is a major component of methane leakage to the atmosphere. This is again the methane cycle. I won't repeat it. This is in a nutshell how these gases are produced. As you have already discussed, carbon dioxide is produced by burning of the fossil fuel, coal, petroleum products, natural gas. Cement industry is a major source of carbon dioxide from deforestation, burning of the biomass. Methane comes from leakage from the gas pipelines, oil fields, agriculture, livestock, and landfills. Nitrous oxide comes from the agriculture, especially the ammonia, urea, agriculture fertilizers, from the rocket fuel, and racing and laughing gas parties. We already discussed the fluorocarbons. They come from the refrigerants. They are synthetic. They are cooling agents and cleaning agents. What is the concentration of these gases in the air? Carbon dioxide is parts per million parts. Methane is in parts per billion parts. Nitrous oxide is also parts per billion parts. But CFC is in very small amounts, parts per trillion parts. How long they live in the atmosphere? What is the problem if they come, if the natural cycle is there? Even if the natural cycle is there, carbon dioxide remains in the atmosphere for 300 to 1,000 years. Methane remains for 12 to 15 years. Nitrous oxide for 120 years. Fluorocarbons can remain for thousands of years in the atmosphere. Then we will discuss about global warming potential of these gases. If we consider carbon dioxide to be one, methane is more potent than carbon dioxide, around 28 to 36. Nitrous oxide much more, and CFC is much more. So we have this is the life cycle of carbon dioxide in the atmosphere. For 100 years, 40% of the carbon dioxide may remain in the atmosphere. 20% after 1,000 years, even 10% remains 10,000 years. Methane remains in the atmosphere for 12 years. Nitrous oxide for 100 years. Fluorocarbons around 1,000 years. This is just graphic represents the global warming potential of the different greenhouse gases. If we consider carbon dioxide to be 1, methane becomes 25, nitrous oxide will be 300, and CFCs become 1,000 to 10,000. But again, are they helpful to us? Yes. Initially, before the Industrial Revolution occurred in around in the end of the 18th century. But these gases are present in the earth since long by natural methods. They keep the earth warm and cozy because of the greenhouse effect. And this is conducive for life to grow, both animal life and plant life. What would happen if there is no greenhouse gases? First, let us consider another planet, a black body, just like the Earth, at the same distance from the sun, which absorbs all the radiation. It doesn't uh, absorb any radiation. It doesn't reflect any radiation. It absorbs all radiation. Then the temperature on that subject, on that body will be 5.3 degree Celsius. But Earth's atmosphere reflects back 30% of solar energy. So the temperature would be around minus 18 degrees Celsius. Minus 18 degrees Celsius will be too cold for the life to survive in that atmosphere. But because of the greenhouse gases, Earth's actual temperature becomes 14 to 15 degrees Celsius. The difference is about 32 degrees Celsius, minus 18 to 15 degree. This effect is due to the greenhouse gases. So they are essential, but in moderate quantities. What happened after the Industrial Revolution? After the Industrial Revolution, there was coal mining, steam engine came into uh, existence, fossil fuels like petroleum products and gas came to be used. So we produced more greenhouse gases. We will see in the graph how the greenhouse gases have increased since Industrial Revolution. This is called anthropogenic greenhouse gases because it is produced by the human activities. It was not there in the natural state, mainly due to the human activities. So use of the fossil fuels started with the Industrial Revolution. This is the graph of different greenhouse gases. Since uh, here the graph is from 1980 to 2020. We will come to that afterwards, why we have taken here 1980. If you look at the carbon dioxide graph, it is slowly increasing since that, 1980 to 2020, and it will go on increasing. Same thing with methane and nitrous oxide. CFC has decreased or plateaued because of stringent measures. Let's come to the change in temperature. Has the Earth's temperature remained same or has there been a change? This graph is from 1880. Already industrial revolution had occurred. Greenhouse gases were already there in the atmosphere. But from 1880 to around 1930, the temperature almost remained same. The average temperature remained same. There was a slight increase after 1940. 1940 to almost 1970, that it remained at a constant level. After 1970 or 1980, we say increase in the temperature of the Earth. The average temperature of the Earth is going on increasing. So here we take as the baseline as 1951 to 1980. This is 1940. This is 1950. If you take up till 1980, this is the baseline. So if you take this as baseline, now we have reached a level of 1.1 degree change in the temperature of global temperature from the base level. And here, 1990, as you all know, is an important year in the history of the world. In a negative sense, liberation started, industrialization became more, and the fall of the Soviet Union, and carbon dioxide level has increased, and with that, temperature has increased. This graph shows both the level of carbon dioxide, how carbon dioxide is and the temperature, how temperature has increased. This is from 1850 to 2000, and this is 2020. First, let us look at the level of carbon dioxide. In 1850, the level was 280 parts per million parts. Today, it is about 415 or 420 at present. Similarly, the temperature has risen from the base level, this is the base level, by 1.1 degree Celsius. This is the average temperature in Odisha since 1950 to 2020. You can easily see how the average temperature has been increasing slowly, almost more than 1 degree. It was 24 degrees Celsius in 1950. Now it is something like 25.5. This is the average temperature of Gujarat. Now, what are the consequences of climate change? We have already seen there is global warming, 1.1 degrees Celsius since the pre-industrial period, or 1850 to 1900. The increase is around 0.2 degrees or 0.15 degree Celsius per decade, per 10 years. And the rise will be around 1.5 degrees Celsius by 2050, and even more than that. As per records, 2023 was the hottest year on the earth. The effects of the climate change are many. One of the effects is the climate refugees. There will be deforestation. Indigenous people, the tribal people will be affected much more than others. Already we have discussed what WHO want. Climate change is the greatest threat to global health in 21st century. The consequences of climate change are faster than expected. What the scientists were expecting, the changes are much more than that. Even in case of 2023, scientists say that we didn't expect that increase in temperature will be so much, and 2023 will be the hottest year on in the history of Earth. The consequences we know: wildfire, forest fire will be frequent. It has occurred in every continent, whether it is Africa, Asia, even in Siberia, the coldest place in the earth, the forest fire is there. In Greece, in Europe, Greece is not a hot country, but there was forest fire for months together. In California, there was a forest fire for so many months. Turkey, the Amazon jungles, the tropical forest. Then comes the drought. Because of the heat wave, there will be droughts. We all know the extreme rainfall, unpredicted rainfall, tropical storm or cyclones and hurricane. And we people in Odisha, we know the frequency of the cyclones and how they have increased. Then the change in the precipitation pattern in the rain, then flood, landslides, cloudbursts. In India also, cloudburst has occurred in Himalayas. All the countries in the world have been affected by the floods in recent years. Germany, China, Belgium, USA, Canada. Though another most important thing is the melting of the glaciers and the ice sheets. The northern part of the Earth, the northern hemisphere, either the Arctic or the Antarctica, the glaciers, the ice sheets are melting, and that causes rise in the sea level. Since 1880, the sea level has increased by 8 inches, and by 2100, it is estimated that the sea level will rise by 1 feet to 6.6 feet. And many countries in the world, many island countries in the world will sink because of this. Not only these island countries, even in India, there are many cities like Bombay and Kolkata, will be affected by the rise in the sea level. Then another effect is on the permafrost. We'll discuss it in detail. These are the permanently frozen layer under the earth. They remain below 0 degrees centigrade, especially these are found in Siberia, China, Canada, Alaska. It is said that 15% of the land mass in the northern hemisphere has permafrost. Because of the global warming, there is thawing or melting of this permafrost, and they release carbon dioxide and methane to the atmosphere. This is the permafrost. This is the active layer or the ground surface. The layer below, this is called permafrost. This remains frozen for more than 2 years. Then it is called permafrost. Here, this is the ground surface. This is the active layer. This is the permafrost. This is the unfrozen ground. And the thickness of the permafrost can be more than 1 mile also. Please give me 1 minute. This is a massive permafrost crater in Siberia. We all know Siberia is a very cold place, remains under ice throughout the year. Because of the global warming, there is thawing or the melting of the permafrost, and it has created big craters in Siberia. These are the consequences of the global warming: droughts, melting of the glaciers, thunderstorms, floods. We have already discussed about the rise in the sea level. This is the minister of Tuvalu. Tuvalu is a country near Australia in the Pacific Ocean. During the COP26, COP means Conference of Parties. This is a climate conference which occurs every year. All the nations of the world, they attend it. In COP26, Tuvalu's minister, he spoke from his own country via the webinar. He stood in knee-deep water in the ocean, and his speech was, "We are sinking." It was a message from all the island countries in the world that the island countries are sinking, and the climate threat is there. The world should act immediately. It is already too late. Tuvalu is a country in the Pacific Ocean near Australia. This is Tuvalu, surrounded by ocean. Think what will happen if the ocean rises by 2 feet. This is the Marshall Island, again another island in the Pacific Island. There is a threat that it will sink. There are other islands also, like the Marshall Islands, Maldives. Let's come to the Indian scenario. We have heat waves, droughts, forest fire, floods, cloudbursts, landslides, cyclones. World Bank estimates that the GDP will be affected by 5.2% by 2050 and 9.9% by 2100 due to global warming. What will be the health impact? There will be increasing malnutrition, child stunting, the growth of the child will be stunted, and poor will be more affected. This is a WHO data. Child stunting is projected to increase by 35% by 2050. Malaria, dengue, other vector-borne diseases will increase, diarrhea will increase. the overall rise in mortality and death will be there. This is the World Bank report on the climate change impact on India. Frequent spells of extreme heat in wide areas, this will significantly impact the agriculture, so the economy. Changing rainfall pattern, reduced rainfall since 1950. The frequency of heavy rainfall has increased. Abrupt change in monsoon causing floods and droughts. Droughts were increased from 1987 to 2010. The groundwater level will fall. Glaciers in Himalaya are melting. Sea level rise will affect Mumbai and Calcutta. Migration of people from the affected areas will cause climate refugees. Are the risk countries not affected by this disaster? They are also affected by if you go by the data of USA and Canada by NatGeo, they have also been affected by the climate change or the global warming. Now comes, who is responsible for this? Who is producing more greenhouse gases? We'll consider this on certain terms. Who are the countries emitting greenhouse gases at present? What is the per capita greenhouse gas emission in different countries? Then comes the historical greenhouse emitting countries since industrial revolution. Greenhouse gas emission of the rich and the poor, and who gets affected. We know who gets affected. It is the rich and poor countries, every country will be affected by greenhouse gas emission. It is not the question who emitted it or who is emitting it. Everybody will be affected by it. Because greenhouse gases do not know any boundaries. They do not know who emits it. They come to the atmosphere and they have their effect. If you go by the greenhouse emissions by each country, the present data, China is remains in the top. Then comes the United States. We are on the third position in India. Then comes Russia, then Japan, Germany, Iran, and so on. These are the main greenhouse gas emission countries at present. As we saw in the last graph, China is the highest one, then comes US, then India. But there is a lot of difference. China emits 27%, US 11%, 6.6%. And all the European Union countries combined together, 27 countries, they are 6.4, Indonesia 3.4. This is the present status. But when you say that these countries, especially China and India, say, we are emitting more greenhouse gas at present. But historically, we didn't emit such gases previously. Means we got independence in 1947. China became a socialist country, got by revolution, it came to existence in only 1949. So our history is less. The countries with largest cumulative carbon dioxide emissions since 1750. And here comes the first position is USA, then Soviet Union, then still China is in the third position, Germany, United Kingdom, Japan, France, India. India is also there here in the cumulative list. If we add up all the carbon dioxide emission that we had done since 1750, this is the position. Next comes, then people say, we have a large population, so we are emitting more. Then comes the per capita carbon emission. This was a 2016 report. If you look at that, United States is the highest position, then Canada, then South Korea, then Russia, Japan, Germany, then China. This graph takes into account the per capita emission and the total emission. This is the cumulated carbon dioxide emissions since 1800. As we have seen, it is the USA is the highest. And then comes Russia, then China. Uh, in COP, they have made certain countries as Annex 1 countries. The Annex 1 countries produce more carbon dioxide and methane than the rest of the world. They produce about 70% of the greenhouse gases. This was the first 10 countries which emission of the countries were on the top list, and the rest of the world. The rest of the world emits is equal to what all these top only 10 countries emit. Then comes who emits most in one country. Even if we take USA or India or any other country or China, who emits most? Is it the rich or the poor? The top 1% earners, they emit around 72%, and top 10% around 25%. But the bottom 5%, 50%, it's negligible. So it is the rich who are emitting more carbon dioxide and more methane because they are using more fossil fuels, more energy. If one family lives in a 15-floor apartment, they will naturally emit more carbon dioxide. If one person goes by a chartered flight, then he emits more carbon dioxide to the atmosphere. This is the predicted emission of the rich and poor by 2030. Again, richest 1%, if we take this as the average one, they will emit more than 30 times the level. But poorest 50% will be less than the average. This is the unequal emission that is going on. So there is inequity in climate. In India, the data shows top 20% emit 7 times more than lower 20%. Average per capita emission is 0.56 tons per year. Then again, a rural-urban divide. Urban people emit more than the rural people. In the world, richest 1% account for more than twice of the lowest 50%. So the elite or the rich need to reduce their carbon footprint by a factor of 30 to reach the Paris Agreement goal. The same thing is given by Oxfam report, the confronting carbon inequality or carbon footprint. Again, the unequal emissions, rich versus poor. This is a report from the Stockholm Environment Institute. Super rich and the celebrities, they have multiple mansions, islands. Even some people live in one family living in an island. They have private jets, yachts. They emit a lot more of carbon dioxide. A new fancy that has come, the space tourism. All these companies are in the race. Amazon, Virgin, Tesla. One trip to the space, it will be 11-minute flight. What will the carbon footprint? It will be 17.5 tons per passenger. 1 billion people in the world emit 1 ton per year. So in their whole lifetime, they emit less than 75 tons per person. Now, in the recent COP28, which was held in Dubai in November and December, this is the message from the UN General Secretary. Earth's vital signs are failing. There are record emissions, ferocious fires, deadly droughts, and the hottest year ever. 2023 was the hottest year ever. We are miles from the goals of the Paris Agreement. The Paris Agreement was that we will limit our emissions so that by 2030, we will, by 2050, we will have a 1.5 degree limit. But that is not achievable by the way we are going. That's why he's saying, and minutes to the midnight for the 1.5 degree limit. Again, he says, we have the technology to avoid the worst of climate chaos if we act now. But we need leadership, cooperation, and political will for action. And we need it now. It's too late. We have to act, and to act now. Uh, this is the COP28 stage. One positive thing from India. This girl, Lise Priya, is a 12-year-old girl from Manipur. She barged into the stage with a placard, and fossil fuels save our planet and our future. A positive sign from a youngster of 12 years age, a girl from Manipur. We all know the situation of Manipur today. The ethnic violence is going on. The vested interest is fomenting this trouble. But in spite of all this, a girl from there goes to the COP28 stage as this. Visipriya is the voice of the younger generation. What she says, your actions today will decide our future tomorrow. We are already the victim of climate change. Sacrificing the lives of millions of innocent children for the failure of our leaders is unacceptable. Millions of children like me are losing their lives, losing their parents, and losing their homes due to climate disasters. Instead of spending billions of dollars in war, spend it on ending hunger, giving education, and fighting climate change. We want clean air to breathe, clean water to drink, and clean planet to live. Demanding this is our basic right. I will conclude with this. Thank you all. I could not cover everything because it will be too long. The subject is very vast. There are many things to be discussed, like the COP, the different COPs, whatever the resolution of the COP, whatever the commitment, and how far have we gone to ratify the commitments. If you have any questions, please.